Me and Julian are going to talk about deploying XenApp on AWS. We originally were not going to present together, but we had two sessions on similar topics, so we've kind of very quickly mashed the slides together, and we'll see how it works out.
Yeah.
I'm Sean Ritchie, got my own consultancy, which is EUC Consulting, and there's my Twitter handle there, and my website euc.consulting, where my blog has moved to now.
I'm Julian. I'm a consultant in France. My Twitter is right there in case you don't follow me and you wish to on my blog when I have time. You know, those of you who know me will laugh. I mean, I have two and a half blogs for the last 6 months, blog posts, but I hope I'll do better one day. So let's go. We can, well,
So I'm going to just sort of start with an overview of AWS, and then Julian's going to do talk about his automation scripts, and then we'll both talk about our power management scripts as well. AWS, these are the AWS regions. Within each region, you've got availability zones. That's what the number on the map is. And within those availability zones, you've got multiple data centers within each availability zone. And then between those data centers in the availability zones, you've got, I think it's about 1 or 2 millisecond latency between those. The VPC stands for Virtual Private Cloud, and it's the customer's isolated network within AWS. And your VPC cannot span regions, so if you have multiple regions, you have to have multiple VPCs, and you have to connect those together. VPC can span availability zones, and it's always a good idea to do that, definitely. And
so that session was planned, and this is the other one.
Yeah, we started, yeah.
You have 30 minutes.
Yeah, that's fine.
Wow, thanks, Alex.
Speed it up.
So within your VPC, you've got private subnets and public subnets. So your private subnet is where you put your VMs and your instances, and your public subnet is kind of what you'd call your DMZ, I guess. Your DMZ is where you put your internet-facing stuff like NetScalers, etc., or web servers. And then you have a NAT instance, which will do the NATing in between those. And then your Elastic IP is your public IPs. EC2 is the Amazon Compute layer, and an instance is basically a virtual machine. You've got loads of different instance types. You've got GPU, you've got dedicated instances. They've just brought out dedicated hardware, so for stuff which is licensed on a hardware machine level, they've just brought that out.
Opens the possibility to bring your own license, right? And you need to run a dedicated host in Amazon, so you can do that as well, right? Leasing, license leasing is not the same, the only model they have today.
I don't know the pricing of that, but I guess it's...
Yeah, please.
Could you talk a little bit louder?
Oh, okay, we'll try. A bit louder.
Thank you.
Louder, yeah, okay.
Okay.
Yeah. So your instances, you only pay while they're running, and then when you stop them, shut them down, then you just pay for the storage that they're using. So this is a very good website, ec2instances.info, that is not owned by Amazon, but it will give you a list of all the machines, and I think it's much better than what you get on Amazon. It gives you all the different sizes, prices, number of cores that you get, memory, etc. the storage in AWS, so in EC2, all the new VM, the new instances now come with SSD as standard. There's no shared storage between the availability zones at the moment, and there's no shared storage at all. So you can't do anything like clustering. They are at some point going to be bringing out Elastic File System, which will allow you to do that. But it was announced in April 2015, and I haven't seen it since. It's still in.
It's still in Oregon, the demo in Oregon.
Yeah, only in preview in Oregon. Right. And then you've got, so for your storage you get a certain amount of IOPS per gigabyte, I can't remember exactly.
3 IOPS per gigabyte.
And then you can buy provisioned IOPS, which gives you dedicated IOPS basically. You can snapshot your instances, but it's different to how it works within vSphere. And if you want to roll back to a snapshot, you actually need to create a new instance from that snapshot, basically.
Yeah.
And then you've got the other types of storage, S3 and Glacier. I'm going to just skip through this because I know we don't have loads of time. So this is a Snowball device, which is basically if you need to get a load of stuff into AWS quickly, they'll ship this to you, and you can put 80 terabytes on it and ship it back to Amazon, and they'll put your data into, I think it goes into S3.
Yeah, it goes to S3 natively, and this is probably the fastest way, to move data from on-prem data center to Amazon.
Yeah.
Guys, is there a charge for that box? Or is there a charge for the service?
No, absolutely free of charge. They'll ship it to you. It's like buying on AWS.com. Same thing.
When I did my project, this wasn't available it's only just become available in Ireland. So it wasn't available then, but it is now available in the EU. So IAM roles is a way of assigning permissions to users or instances within AWS. So you don't want to be using the root account, basically. That's kind of something that's going to be held by probably like director level, and you just assign IAM roles to users, and you can assign IAM roles to other instances within Amazon, which allows those instances to then do stuff like run scripts against.
Get access S3, for example. This is a very good example. If you want an instance to get content from S3, you'll basically just do an IAM role for that and allow S3 access.
Oops. Right. Let's go on to the Packer stuff, and then we'll go back to that.
A very important thing, when it comes to Amazon, is to build stuff differently than we used to do. On-prem, right? For very simple reasons. Rare are the customers who say, "Oh, you know what? I want to put 400K to move my Xen to Amazon." They go. My customers, at least, on the projects I work for, they go first with the application. They move the applications to the cloud, and when they have it, they say, "Oh, how are people going to access that?" And this is where you kick in with Xen out, and you try to pull that stuff, right? So building things, in Amazon requires a certain set of skills and knowledge of certain tools that are very commonly used in Amazon. One of those is Packer, which is basically an open source image management tool, which is based on a single configuration file and which is absolutely provider agnostic, meaning that with a single Packer configuration you can build on Amazon, Azure, even on vSphere if you like. So basically you will be building your templates very similarly as we do with PVS and MCS. So this is basically how it works. The Packer is a simple exe you put on your machine, right? And once you have a VPN connection or any form of connection to your VPC, to your Amazon data center, right? You will set some configuration in the JSON file, like instance types, scripts that you want to run in sequence. You power that on, and the build is coming, right? So this is how it looks like. You'll define a certain number of variables like source AMI, region, build VPC, build subnet, instance type. I'm using Chocolatey, for those who know me, a lot to build automatically on Amazon. We'll get to that later, so I'm setting my repository there. And on the other hand, this is typically an example of how the JSON configuration file looks like. So basically this file, this config file, will read those variables, use them, and do stuff you're telling him to do. So I think that it would be really cool to see live, right? So if my internet connection works, and I hope it is, I'll try to show you that live. So, as I said, this is an example of a JSON configuration file for Packer. So basically, what we'll be building here is a golden image that will be used after for our build process. This golden image will basically start from an instance which is an ISO in Amazon Cloud. Open that ISO up, configure it, put your stuff into it, sysprep it, close it down, and put it away, right, for the future usage. So we don't have much time. The whole thing I just want to say is that it looks quite strange when you see the syntax, but basically on the backend what is happening, the Packer will be running a certain number of PowerShell scripts. And the beauty of this product is that when you take all these variables aside, when you see the builder type here, it's an Amazon EBS. If I change this to Azure or whatever, I will basically run the same code and build an instance, an AMI measure. And this is really cool. The same thing goes with ESX, etc., etc.
So in AWS, your AMI is basically like a template. So it's like a template in vSphere, it's a template.
Absolutely. And here are the parameters, right, that I will be using, meaning that you can go to any customer, just modify these, right, and I'm using some system of variables. This is my S3 storage where I'm storing the binaries when I'm on the cloud, my Chocolatey repository. All those things are basically going right into my template, and the build is kind of starting as soon as you click. The machine will, by API, connect to Amazon, right? Build an instance. I think we can see that live here in a few seconds. The machine will be created. I'm in MI, sorry. Okay. Yeah, this is it. The machine build is initializing, right? Started now at 4 p.m. Machine is being initialized, and you will see what the Packer will be doing. Basically, it will wait for the instance to be ready, and now it's waiting for WinRM to be open, right, in order to start running these scripts, which will basically configure your environment, right? So this whole process that takes around 10 to 15 minutes, and the result, because we don't have time, I'll show you here. The result.
We've got 25 minutes with it.
More. Oh, great. Great, Alex, it's very nice. Basically, what you get is a custom AMI, which is basically fully sysprep with all your tools inside, everything is specified in your PowerShell code. So basically, that can be almost anything. I mean, you can even put software inside. This is what I'm doing when I'm building workers, right? So when you check the scripts, for example, one of the first scripts that you do in order to make machine available to your Packer, right, is, well, I see, probably the best idea. whatever, is kind of configuring WinRM enabling partial remoting, right? Opening up firewall, because in Amazon nothing is open by default, so you need to open up the firewall to be able to connect to WinRM. So this is the first thing you'll be doing. And the second thing is, after you add the configuration, the Windows updates, cleaning and bundling that up, running just custom sysprep, I mean, everything is there. And one more time, all those things are basically in the variables. There are tons of things you can add on the fly. For example, your source AMI, your domain user account that you will be using for joining machine into domain and running sysprep, putting it in the OU. So I mean, which makes this build factory extremely flexible, adaptable to any context in a matter of minutes. So basically, very soon it will connect as soon as the machine is ready. I think which will happen in a few minutes, initializing still. So basically, this is say 20 to 25 minutes process, and you have your template you can start using in production, right? So this is one thing which is extremely important when it comes to Amazon builds, to adapt to the process to the way the Amazon works, right? MCS simply doesn't fit because the customers are using Packer for open source tools, open source stuff. You must have the same way of provisioning stuff, cross-platform, right?
Yeah.
I'll take this. And the other thing which is extremely important while the machine is being built is power management. At one point, Sean said that when you're not using your machines, they should be off. This is extremely important when it comes to XenApp because we're talking about very big instances, right? So traditional way of scaling in Amazon, simply doesn't work because it's too expensive. If you don't know how your applications are being used and how much memory CPU is being using, and you say, oh, whatever, I'll kind of put 8 CPUs and 64 gigs of RAM, your customer is going to kill you, right? Because this will cost like $4 an hour. I had that problem with one customer who engaged with the project in XenApp, and it cost him a fortune to run instances on Amazon. So he asked me, is there a way to dynamically power off machines when they're not being used and powering them on when they're really needed, right? In order to shrink the instance size and run the production the minimum number of machines, right? So I was thinking on Power Manager, we had XenApp 6.5. This thing doesn't exist anymore, right? So I had to write my own power management script that does that. Basically, based on the context, if the customer, based on delivery groups, I can make a decision if, for example, the load is lower than the threshold or higher, dynamically power on machines, and when the load is going down, dynamically power off the machines, of course respecting the fact that the sessions are still running, so draining the machine slowly, making intelligent decisions, start to drain servers with least connections, with highest number of disconnected sessions in order to make the drain process as faster as possible, to make as much possible, economies to the client. This is something that I've been working for a very long time. Today it's running in production. If we have time, I'll be more than willing to show you how it works. At the same time, Sean had the same problem with his project when he also wrote a piece of code that's doing very similar thing, but through MCS, while I'm doing that completely independently, right?
Yeah. So I did one for my customer, which was for XenApp 6.5, and I used talking directly to AWS for that one. Then I wrote another one which I've put on my blog, which is for XenApp 7 and above, which uses the hosting connection to talk to either AWS, or it will work with vSphere or Azure or whatever. And so it uses the hosting connection to power machines on and off. And Julian's one actually builds new machines, right?
Absolutely. In case when you get to a situation where, imagine, you have sized your delivery group for 10 machines, and then somebody comes in with an application upgrade and it takes twice as much resources. Your 10 machines will kind of go in 10,000 within half an hour, right? So what I'm doing basically, I'm starting production with a certain number of machines I'm reserving, say 20%, split it into two availability zones. And as the load is going up progressively, I'm powering on machines, right? By kind of 20% threshold of machines that are being turned on every time I detect a high load condition. And then at one point, if I power on all the machines and I'm still really, really high, well, I need to build those machines, right? I could also send an email to a customer saying, you know what, your production is about to die. But I said, okay, I'll try to be proactive, because if you build stuff using the Packer, you can basically create an image for every silo, meaning that from my code, I can call an Amazon API and say, look, how about you build me 2 of those now, right? Machines of this type with this AMI instance, etc., etc. So technically, I can build new machines on the fly when this is required, right? I don't know if we have time. I could probably show you that in a in a few seconds.
I think your script as well is logging to the Zen desktop log, right?
Yeah, absolutely.
Mine is doing the same, yeah. So
we are both using the configuration logging database, right? So,
yeah.
So are your machines on static IP addresses?
With Amazon, they are definitely. I mean, this is how Amazon works.
Yeah.
So let me show you the code. Right. So basically, what is happening here is that, okay, I was playing with this morning, so everything worked well, right? I'm generating an event, calling auto-scaling event, when the load is lower than a threshold. In my case, this is 4,000. This threshold is randomly set. It can be 3, 2, whatever. I can also, with this code, reserve, as I said, certain number of machines, 20, 30% per each delivery group, and keep them all the times up and running. And also, I can say, in case the customer doesn't want to load manage a certain delivery group, I can exclude machines. I'm just using Zen desktop tags, right, to do that. And what is really happening is that whenever there is a low load or high load condition, I'm writing basically a line in the database. This is a basic log used for administrators, platform operators to know that something is going on. For example, somewhere around when we were playing with this with Sean a few minutes ago, well, for example, this machine was powered off, right? Because user activity was not detected, and there was a kind of power management action going on. So, at this moment, on Sunday, I don't have too many users on the platform. So what I will do, I will power on those 2 boxes, XA 5 and 6. Those boxes are running on Amazon. What is very interesting is this code can work in a hybrid environment. My platform is hybrid. I have half of my workloads in my data center in Paris. The other half is running in Amazon, right? Including the stretch always-on cluster between Paris and Ireland. And all the Citrix roles are equally split between those. So basically, 3-point resilience, Paris, AZA, AZB. This is a 7/8 platform, so I have 2 zones, Amazon and Paris, of course. So I'll try to show you how it looks like. Now the 2 machines are being powered on. Let's try to see how it goes. These machines should get to be initializing this state very soon. It takes a few tens of seconds to power on machines. So we'll be patient.
So for my script, I assigned IAM roles to 2 instances in AWS, and I run the script from those instances, and those instances have permission to turn machines on and off.
So the machines are being initialized, so it will take some time to get to the register phase, and if the load is still lower than 4,000, the machines will be automatically powered off. So meaning that even if an administrator, right, decides to power on machines, all of them, the code will shut them down. If this is something you want, right? You can always override that. There is an override switch, meaning that if for whatever reason you want your old machines to be running, this is absolutely possible and can be done by using the simple partial command. It will type the delivery rules and the code will basically skip them.
Yeah, that's what my customer wanted a kill switch in the script. So my one looks at a share, and you basically just drop a text file in that share.
Right.
If it finds that text file, it just powers everything on and quits the script, basically.
Yeah, so basically we can see that in my platform now, the machine 1 and 2 are running in Paris 3, 4, 5, 6 are in Amazon, right? So we have a one session on machine 2, 3, and 4, and machine 5 and 6. 5 and 6 are currently registered. So let's see when was the last script run. Let's say, I think the next one running approximately 2 minutes. I will try to help him a bit. Basically, the code is running as a scheduled task, running every 5 minutes, which is also something you can configure, right? So if the load was lower than 4,000, and I think when this will start happening now, I think maybe the load was higher before because we spin the machines though, so the machines temporarily get the load which is a bit higher. Let me check that in the debug log, because this is also something I wanted to show you, is that at one point I had this generic log, which is really made only for admins, basic admins, right? On the console level, there's a debug log. I'm writing everything that basically the code is doing, so we'll try to figure out what is happening. 2 seconds. So yes, the 4 machines are there, and production plans, I can see everything. Yeah, the load is higher than 4,000, 4,849, and this is the reason why the machine didn't turn off, because it really takes a certain time when you power on the machines to get those load back. But I think if I run it one more time, this time it should be better. We should be lower than 4,000, and the power of action will kick in. Let me see if this is happening.
So the script that I've written, it also runs in a scheduled task that runs repeatedly, and it detects if the script is already running, it will just basically shut itself down. So, and then it also runs, it can run on 2 servers at the same time, so the script will check whether it's running on the other server, and if it's running on the other server, it will just quit. If it finds it's not running on the other server because that server's died, then it will take over, and it reads the tags out of Zen Desktop to know where the other script left off, basically.
You've got 3 now.
Yeah, I have 3 now, but my load is higher than 4,000, so.
Well, I mean, you've got 3 event logs saying that it just happened.
Let me see.
Yeah, it worked.
It did?
Yeah, it checks in as the top one.
I don't know. Let me see the console. I think it should. Definitely. No. Okay. This is really live demo. A real beauty of it. Okay. One more time. Run. Yeah.
Click the top entry. See, 16, 16.
I don't.
Worked a minute ago, see? Time 16, 16.
Yeah.
Yeah.
Good.
And okay. So basically, Basically, let me see the log one more time.
There, 3975.
Yeah, one more round. Okay. This is 1, 2, 3, 5. So one more round. Okay, now. Turned off already. No. Okay, whatever. I'm really sorry about that. I didn't prepare just better. Normally this thing should kick in now. I think that should close one more time.
So in for my customer, I was using some fairly large instance types for the worker servers for the session hosts. Julian, I think you were using a lot smaller instances, right?
Yeah, I was using the 4 gig instances. Yeah, I mean he's basically not seeing my machines. I don't know why. I don't know why. He gets them.
So how many users were you getting?
So basically that depends on the application. That really depends on the application.
Yeah.
Oh, when registered. Oh, he did power off machines. Okay. I think maybe it was too much beer yesterday. So I must be missing something. Yes, he did. He did turn off the machines. He did turn off the machines, and there must be somewhere in the logs. But as I said, I think I'm I should drink less when I do presentations.
Just stick to wine.
Yeah, I'll do wine or something. Yeah.
Beer.
So.
It worked, it's good.
So I mean, it worked, which is very positive, right? Oh yeah, here we are. So okay. Thanks, I really appreciate it. I feel kind of stupid when something that works all the time doesn't, right? For whatever reason. So basically, it did work, right? So and I mean, on the other hand, I mean, I've been stress testing this very much, and I have an explanation why I didn't, because basically for a moment the load was really, really high. And he needed to count 6 successive events when the load is lower than 4,000 to kick in.
That was going to be my next question. Yeah, what happens if it accidentally drops below?
And basically, this is what was going on, right? So 2 minutes. So the same thing will happen if the load goes up, right? Machine will power on automatically.
So we have a
Yeah.
lot of time, so we'll just wrap up very quickly. So just go over, I guess, the stuff that we learned from our project. So one of the things I learned was before you kind of decide to make the move to the cloud, especially if you're running a published desktop, is make sure that your apps that are going to run in that published desktop are going to be suitable for the cloud. So there were, for the customer I was working for, there's some stuff which they had to take out of scope because they just couldn't move the back ends to AWS. They didn't have a very good plan for decommissioning stuff once they'd moved to AWS, so that they kind of had AWS cost plus the colo cost. So, and when the AWS bills start coming in, then you get quite a lot of scrutiny from management, etc., wanting to know why they're spending money on AWS and still having stuff in a data center. You can port your images into AWS, so you can actually just take a vSphere VM and port it into AWS, but it's not really a good idea. You don't have the EC2 config service in there. So, and the EC2 config service is what AWS uses to talk to the virtual machines, to the instances. So without that, if you phone up AWS with a problem, they will not be able to help you because there's no EC2 config service in there. EC2 config is also what you use for doing sysprep, so you don't use the normal sysprep, you use the EC2 config .exe. There's limits on the number of instance sizes you have, so if you kind of you decide to suddenly ramp up, you might actually hit this limit and you have to, I think now you can take it off in the console, but before you had to phone Amazon and log a ticket with them. So, and I think they do that just in case somebody gets your keys basically and then spins up hundreds of instances within your environment.
Finish.
Okay.
Okay.